Hi, welcome to our session. My name is Jorge Lozano, and today I am joined by my peer Kevin Tien, and we'll be talking today about this topic that we've labeled Analytics-Enabled Experiences, the new secret weapon. Thank you so much for joining. We have very limited time, so rather than going through the agenda in detail, I'll just get right into it. Both Kevin and I work at Steelcase, which is one of the leading office manufacturers in the world. The boring way to think about what we do is to say that we manufacture desks and office chairs. But in reality, we like to think of ourselves as doing a lot more than that. We like to think of ourselves as designers of workspaces. We unlock human promise by creating great work experiences wherever work happens. And Steelcase is a very, very historical company. We were founded in 1912, so over 100 years ago, and it's a company with a lot of history. We're not like one of those digitally natives. We have so much history behind us. In fact, one of the images that you see there is the signing of the Japanese surrender on board the U.S. Missouri in World War II. That document happens to be signed on top of a Steelcase table. So it's a very rich organization with a lot of history. And with that, obviously, comes a lot of problems. So what is one of the problems that we're going to talk about today? The problem that we want to share to you is something that's been on our mind and that's been a challenge for years. And it has to do with our ability to understand how our individual products become product applications. Our saying is that we know how many Lego pieces we sell, yet we don't know what Lego sets our customers buy. Let me elaborate on this a little bit. This speaks to our inability to understand how individual products come together to form a product application. On one side, you see the breakdown of individual products, which is what we manufacture. On the other side, you see what a customer actually buys, which is that product setting, right? And the blend in between those two is often challenging for us to understand and analyze at scale. We know exactly how many chairs we sold, how many screens we sold, how many caddies we sold, but we don't really have that rich information of how these came together to form specific settings. And so the data science team was tasked to try to solve this problem. And it became a very important problem to solve. It became a priority, and we were making some really, really good progress. That is until overnight the world shut down. And our initiative was no longer important. It became critical. Why? Well, it became critical because a lot of the information that we were using to derive these analytics deemed extremely insightful to understand the current state of the North American office in terms of the layouts, the division, the density, and the placement of workers within a space. And so our priorities had to change overnight. And this story is the story of how that change in priorities and mindset and focusing on something broader and bigger eventually led us to a much more successful state. So when we switched the question, now it all became focused or geared towards the idea of how is data science helping corporations bring people back into the office and at the same time set the path to lead the reinvention of the office space. So how did this happen? Well, a lot of the data that we were collecting, as I mentioned, became essential into understanding how our current offices were set and whether that presented a risk for disease transmission. We were able to use this data to understand the distribution of distance between workers, on how often you would have a coworker sitting right in front of you or next to you or behind you with no division to protect you from the disease transmission. We were also able to really understand core templates or frameworks or models of what workstations from our customers look like. And so how do we take this further? Well, we were able to develop industry benchmarks that deemed significant and extremely relevant to guide the decision making from even state and federal government. For example, we developed a framework that would classify workstations based on the level of risk that they would present by its abidance to standard social distance measures. In this case, we were seeing that 78% of workstations did not have enough distance or division to comply with those standard social distance measures. That is a big deal. And that is a big deal when we're talking about worker safety. And so what we began thinking is, how can I fix this? How can we solve this? What happens if I add some division in between workers? What happens if I add some distance between workers? Will it solve the problem? Will it even help? And to what extent? And so to do this, we actually thought that we needed a very solid foundation on science. So for this reason, we decided to partner with MIT to understand the fluid dynamics of disease transmission in an office setting. And we wanted to understand the extent to which our retrofitting strategies would play any sort of effect in mitigating the spread of pathogens amongst coworkers. And so here's where we're at. We have a data-driven starting point that allows us to understand what the most common settings are and what products from within our portfolio could be used to retrofit them. We put these to the test in a state-of-the-art laboratory that tests the spread of pathogens in an office setting. And we use the results for that to understand how should we be thinking about optimizing our retrofitting strategies and propose those to our customers. But that in itself isn't the end. In fact, this is the most important thing that you need to learn from this session. If you really want to be able to change the game, if you really want to be able to turn this into a competitive advantage, you should stop to think about this as a data science problem and think about this as an analytics-enabled experience. In other words, it's not about how do you take data to feed models. It's about how do you take data to create experiences. For Steelcase, that experience became something that we call SpaceScan. SpaceScan is a service that we offer to our current customers on which we're able to ingest their current floor plans, analyze them, highlight the workstations or settings that are deemed as high risk, and propose retrofitting strategies that have been vetted to improve the safety in terms of a diminishing in the transmission of pathogens in the office. And we do that automatically, we can do that at scale, and we can do that in ways that we can optimize based on what the customer is looking for. Are they looking to be able to bring all of their employees back, only a portion of them? Are they more focused on distance? Are they more focused on division? And so this is the secret weapon. The secret weapon is to be able to translate things into an experience. It's not until you make it an experience that you change the game. So the focus is about how do you turn data into information? How do you turn that information into insights? And then how do you leverage those insights to create an experience? How do you do this? How do we go about and do this? And we're going to talk a little bit about that. First, I want to say there's two things that come into play. The first one has to do with the organizational structure, and the latter has to do with technical competencies. This is particularly important for non-digitally native organizations, as it is often the case that our structure is much more rigid and potentially different and non-conducive to resource and execute against these type of initiatives. What I can say, though, is that a very important thing that you should keep in mind is that you don't need a team of data scientists. You need a data science team. What do I mean by this? What I mean by this is that the breadth of resources and skills that are required to transform data into experiences goes way beyond the traditional data scientist. And you need to be mindful of that, and you need to be receptive and set up teams that are conducive to execute against these type of initiatives. I'm now going to hand it over to my peer, Kevin Tian, that is going to talk about the technical competencies that are involved in being able to execute initiatives such as this.
Let's talk about the data engineering and the infrastructure piece of this work. Back to several years ago, when the application mapping work came to the table with all other initiatives, we were all excited about the possibilities. We began to envision how all the information and insights could empower the business. But when we began to architect the solution, we realized that our choice is very limited. It is like we plan to cook a spaghetti with a top-notch secret recipe, but found that the only thing we could use to cook and eat the spaghetti is a hammer. Back then, we were still using our legacy analytical system. To avoid any holy wall or legal concern, let's just call it legacy system. Okay, I can give some hints. It's an industry leader since 90s and a popular name about being replaced in the last 3 years. But it is still popular in highly regulated industry like pharmaceutical and finance. Back to our story. The legacy system could still fulfill our regular analytical need. But whenever we want to push the boundary, we began to hit a wall. The wall consists of two parts. If we want to do that on our legacy system, we need to pay extra money to enable the capability. The other part is, some of the capabilities only works in the marketing materials. Or in another word, it will only work in certain scenario. And our scenario usually is not the certain scenario and will be available in the next release. That happens in 3 key features we need: model deployment, deep learning, and distributed training. So we began to explore the possibilities of modernizing our analytical system, and we finally landed on building a cloud data platform based on Azure Databricks for both data science and data engineering. On the application mapping side, we started by thinking big. Our end goal is more about embedding the analytical-driven solution in the business operation, rather than the standard report or dashboard. But back to implementation, we need to start small. Based on what the data tells us, we move from one step to another. What is our big data problem in applications mapping? The data volume and velocity is high, but can be easily handled by our system. We got more challenges on data variety and the data veracity side. For applications mapping, we need to ingest data of different formats. We got enterprise core data from relational databases, which is easy to consume. Semi-structured data like JSON and XML can be a little challenging. When they come in good format, that is not a problem at all. The native JSON support in Spark and the open source library like Spark XML can handle them accurately and quickly. Unstructured data definitely needs special treatment, usually with special softwares. From data engineering perspective, the challenge will be special software automation and integrate the special software run into the job scheduler. That may require a collaboration with other teams specialized in this area, or support from software vendors. Now let's dive a little more deep in the data veracity problem in the two semi-structured data. Those are 4 JSON messages we got from IoT devices. If you take a look at the first 3 messages, you probably will get the idea. They express the same meaning with different schema. And if you are familiar with JSON schema, you may prefer the first messages as the implementation since it uses JSON native Boolean format. But there is nothing wrong in choosing the second or the third solution, as long as it is consistent. But when all the four implementations exist, that becomes a problem. The first three will fill most of the schema inference system, while the fourth one will be recognized as an invalid JSON. Ideally, the problem should be fixed at the machine side. Fixing the problem in your data pipeline is possible, but will slow down the process, and more importantly, it will complicate your data pipeline. The problem is usually caused by undefined data schema or weak schema design. Schema on read is a great feature in big data solution, but schema on read doesn't necessarily mean no schema. Schema design and validation is still important. Let's take a look at a similar issue on the XML side. In this case, the schema is defined but not enforced. The orientation is defined as 3 decimal, x, y, and z. But let's look at the x value in the data. What does tilde mean here? As a human, I can interpret it as almost 0, but a computer will fail interpreting it and treat it as a bad data. Because of the small problem in one line, the whole XML file with 100,000 lines will fail to work. On our end, the root cause of this problem is that the data may come from different sources. Though some data sources have schema validation before coming into the enterprise message queue, several of them don't. For this particular problem, we ended up fixing the problem in data pipeline, since this is a common problem and fixing the problem in the data source is a human-in-the-loop process. By ingesting the raw data into our cloud data platform, we enable delivering the descriptive analytics faster. On the particular XML parsing problem, it took us 4 days to parse the whole datasets with vanilla Python, but only 10 minutes with Spark XML. With the new platform, we further enable exploratory data analysis by making both raw data and refined data accessible for exploration. The refined data can be either a commonly used data table joined by several raw data tables, a machine learning scoring result, or a result table created by another data scientist for a different purpose. And also the built-in data visualization capability, making visualize the data in any step really easy. The collaborative notebook is a feature shines much more than we thought before. At first, we thought that it's good to have as a collaborative Jupyter notebook. But we ended up using that a lot. That enabled sharing and collaborating within the same team and across teams. I cannot count how many times a data scientist asked me for a feature and I shared my sample notebooks to him or her. And that definitely helped a lot during COVID time, when everyone is working remotely. But as a software engineer or data engineer, that also helps eliminate another famous problem. It works on my machine. We have got that a lot when each of us running Python or R on local machines, but not anymore. When we are doing diagnostic analysis, we want to make sure that diagnosis can be trusted. Thinking of seeing a doctor with an X-ray result, how angry would you be if you know the diagnosis you heard 3 days ago was based on others' X-ray? On diagnostic analysis, the data quality is the top priority. Trust on data is hard to gain and easy to lose. Our first version of the model is based on deep learning. By leveraging a big GPU cluster, we accelerated the training from weeks to a day with comparable cost. But on the other hand, more machines may not solve all your problems, especially when your task cannot be paralleled. In that case, more machines will cost you more and may slow down the process due to the overhead of cluster creation and communication. In the deep learning example, we accelerated our success by scaling on demand, but accelerating is also important for failure as well. This is one example about measuring distance between workers. In this example, we assume the distance between chairs is a good representation of the distance between workers. Then we found an interesting result that 4% of workers are within 12 inches. That is really counterintuitive since most of our chairs are wider than 12 inches. And even in a pair programming scenario, two coworkers should not be that close. So we dig further into the scenario and found headrests are counted as a seat. By eliminating them out of the measurement, we got a much better result. Back to SpaceScan. With the data and information, we created a machine learning model which represents of our insights in helping customers detect high-risk settings. But how can we embed the model into current process? How can we go beyond a presentation or a dashboard? By collaborating with our Smart Tools team, we embed the SpaceScan experience into the design tool our dealers use. Thus, they do not need to go to 10 different places to use the tool. Instead, the feature comes handy in their daily process. We enable the native integration by containerizing our model. The dealer tool will make an API call to the model in the container to receive the result in time. For customers with more strict data privacy concern, we made the container available for edge deployment. That's the sensitive customer information will not be shared with us. The edge deployment will also accelerate the response time, especially for big floor plans. Here covers the technical competency part of the project. Let me hand it over to Jorge.
Thank you so much, Kevin. And so now the question is, where are we headed next? Where do we go from here? Well, there's a couple of things. First is, there's two important things to highlight here. The first one is that the office is here to stay, right? And some of the leading organizations have been very vocal about the fact that they are looking for ways in which they can bring their employees back because they understand the value in culture and innovation that the physical space brings to them. However, we understand that employees are not going to want to come back to the office that they left because people now have new needs and expectations. And this forces a need to rethink the role that the office fulfills on the worker. And so new design principles will prevail, and we need to be mindful and adaptive to those. What this is creating is a revolution, and we need to be mindful of that revolution. So how do we stay on top of it? How do we stay connected to it and understand the things that are changing? I think the most important thing here is to make sure we always remember that we don't sell what we build. We build what our customers are willing to buy. And this slight distinction is very important because understanding that distinction implies that we understand the need to stay connected to our customers and to understand their ever so changing needs. So how do we do this? What we want to be able to do is we want to be able to build a digital thread that can empower the creation of a flywheel that allows us to stay connected with our customers across different points of the journey. We know that the value generation coming from a digital thread will unlock the potential across our business, not just today, but tomorrow.
How can we further enable the office revolution from the data engineering side? First, we need to focus more on the near real-time data collection. Currently, most of our pipelines work in a batch fashion. thus the insights generation is days or weeks behind. Migrating most of our pipeline into streaming will enable near real-time data collection and faster insights generation. Second part is about catching the trend. Again and again, customers ask us what the future of office would be like. As a thought leader in the area, our research team collaborates with top-notch researchers around the world. But from our side, catching the data drift in design and code will definitely help understand what is happening in the field at a large scale. Also, data could further push the several qualitative research ideas into quantitative measurement. The last part is to broaden self-service analytics to dealers so they could generate insights based on their own needs. Of course, this needs to be done right, since the data governance and the security rule would be different from our current model. Thank you all for attending this session.